Hello everyone, today I'm going to talk to you about statistics, the t-test, specifically the matched pairs t-test. So first, a problem statement. Scientists are interested in the placebo effect on adults with arthritis. They randomly choose 15 adults with arthritis and give them 2 treatments, effective drug and placebo, for 1 week at different times. This different times is very key because it signifies that we should use a matched pairs t-test. Because it's the same subject at different times, thus the subjects are not independent. Use matched pairs. At the end of each week, the scientists ask the participants to rate their arthritic pain level on a scale of 1 to 5, where 1 is little pain and 5 is a lot of pain. The researchers then take the difference of their pain levels, the effective drug minus the placebo. The data are below. Find the 5-number summary for the difference of arthritic pain levels using SALT, a statistical software. And we are going to begin by filling in this table using SALT. So this is the web page, SALT statistics. We will go to the descriptive statistics, and over here we can see that the mean value is negative 0.2. The standard deviation is 2.1778. The population size is 15. The minimum value is negative 6. The Q1 is negative 1. The median is 0. And the Q3 is 1. And the maximum value is 3. Back to our presentation. We can thus see that the minimum value is negative 6, the Q1 is negative 1, the median is 0, the Q3 is 1, and the maximum value is 3. So part B, one of the conditions for inference for population mean difference of paired data is normality. Outliers within the dataset cast a shadow of doubt upon the normality of the population distribution. Use the 5-number summary calculated in part A to determine if there are any outliers in the dataset. Which of the values, if any, is an outlier according to the outlier rule? I've highlighted the key words. So normality, outliers, and the 5-number summary. And here is our 5-number summary that we are going to use. Remember that the interquartile range is Q3 minus Q1. Low outliers are numbers that are less than Q1 minus 1.5 times the interquartile range. High outliers are greater than Q3 plus 1.5 times the interquartile range. And for the low outliers, we can calculate it by plugging in the respective values from our table on the left, and we get a value of negative 4. So any number less than negative 4 will be a low outlier. We see that there is indeed one number, that is the negative 6 number over here, that is less than negative 4. Next, the high outliers. We plug in the respective values, we get a number 4. But there are no numbers that are higher than 4, so voila. Despite your answer to part B, assume the conditions for inference have been met. Using the sample standard deviation S.T.E is equal to 2.18, calculate at 95% confidence interval for the true mean difference of arthritic pain levels. Use a table or technology and round your answers to 2 decimal places. So keywords is assume. The standard deviation is 2.18. A 95 confidence interval, and round your answers to 2 decimal places. The general formula for confidence interval as given below. The mean plus or minus the t-score times the standard deviation over the square root of n. The x bar is known as the mean. The sigma over the square root of n is known as the standard error. The t-score we can find the t-score in this way. So note that this is a paired t-test. Remember that we have 15 adults but 2 treatments. The 2 treatments is prescribed to each of the 15 adults. We can have 15 groups then. So the degrees of freedom here will be n minus 1. N would be the population size, which is in this case, in the matched paired t-test case, it is the number of groups. The number of groups is 15, minus 1 is 14. At 95% confidence, which corresponds to alpha equals 0.05. So we go to our t-table now. Here we have our t-distribution critical values. Remember that we're looking for 14 degrees of freedom at 95 degrees confidence interval. So we scroll down, we see 14 is over here. Let's see if we can annotate. 14 is over here, and the 95-degree confidence interval is over here. So we draw a straight line up and see where it intersects with 14. It's over here. So our value of interest will be 2.145. As we see here, t-score is 2.145. And we have a mean of, remember, the mean of this data set is negative 0.2. The confidence interval, plugging in all the numbers we need, we can get the confidence interval of negative 1.41 to 1.01. Now let's move on to part D. What will happen if the scientists increase the sample size? Continue to assume that the conditions for inference have been met. Using the sample standard deviation of S.D equals 2.18 and the same point estimate, calculate a 95% confidence interval for the true mean difference of arthritic pain levels if a sample size of 20 were used. Use a table or technology and round your answers to 2 decimal places. So our confidence interval, remember, this is the general formula. We want to change sample sizes. So the degrees of freedom is 20 minus 19. So changing sample size changes the degrees of freedom and the square root of n. So basically it changes the t value and it changes the square root of n. So the degrees of freedom is now 19 and the square root of n is now square root of 20. The new t-score will be equal to 2.093. If we use this table, we can see that. Again, here we have our t-distribution critical values, and we're looking for degrees of freedom 19 at a 95% confidence interval. Scroll all the way down. So that'll be a value of 2.093. Confidence interval of negative 0.2 plus or minus 2.093 times 2.18 over root of 20. So basically that's a confidence interval of negative 1.22 to 0.82. That's the end of this video. I hope that this matched pairs t-test example was helpful for all of you. And I'll be seeing you guys soon. Thank you guys so much for watching.